Hello, dear first grade students. I am Mr. Ahmed Magdy, your math teacher, and today we have a new video explaining 3 lessons, but they are very short lessons and they all depend on one idea, which is the idea of subtracting decimal numbers. But each lesson talks about a specific method, okay? The first lesson talks about estimating the result of subtraction using the same strategies that we used in the previous lessons in addition, but we will depend on only one method, which is rounding to the nearest digit. Okay, so why don't we try and solve some examples? First, I have here 39.79 minus 20.027, okay? And I want to estimate the difference here, okay? So I want to round each number to the nearest digit I will choose. And in the first one, I will choose to the nearest tenth, okay? So let's talk about here 7, and the second number here I have 0. 7, the next digit is 9, so 9 is a strong digit, so I will add 1 to 7, so it will be 8. And the rest of all digits stays the same, and 9 will be cancelled, okay? This is the first one, okay? And second, so it will be 39.8 minus. The second one here I have 0 in the 10th place, and the next digit is 2, and 2 is weak digit, so I will save 0, or I will stay as 0. I will keep 0 as it is, so it will be 20.0, okay? So it will be 8 minus 0 equals 8, and 39 minus 20 is 19. So the estimation here will be 19.8. But what is the difference? That we will talk about later, okay? Next, in the second one, I will choose the nearest tenth, okay? Or maybe I will choose the nearest ones or the nearest unit, okay? So I have here 8, and here I have 1. The next digit here is 9, and the next digit here is 7. 9 here is a strong digit, so I will add 1 to 8, so it will be 8 plus 1 equals 9, and 1 stays the same, and the rest of digits will be cancelled, okay? So it will be just 19. The second number here I have 1, and the next digit here is 7, and 7 is a strong digit, so I will add 1 to 1, it will be 2, so it will be 12, and 7 will be cancelled, so I have here just 12. And 19 minus 12, it will be 7, so our estimation here will be 7 for the second operation, okay? Next, in the second and the third lesson, we will talk about modeling the subtraction operation using models or the place value chart, okay? So if I want to use the model to represent the operation, first I will have a model like this: 1 square of 100 parts, okay? Next, I will shade the model to represent the minute. So it will be here 0.52 or 52 hundredths. So first, I will shade the model like this. So I will shade 52 parts or 5 columns and 2 parts like this. So it will be the first number here. I have 10, 20, 30, 40, 50, and after that I will shade 2 parts. So I have here 52 hundredths. Next, I will add some x's to represent the subtrahend or the next or the second number. Okay, so I have here 14 hundredths or 15 parts of 100 or 0.14. So I will delete 14 parts of the model like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And next, I will count the shaded squares without x's, which is the difference. So let's count the rest of the parts. So I have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38. So I have here 38 parts of 100. So the result will be 38 hundredths or 0.38. Okay, or maybe if I want to use the place value chart like this, so I will have the chart like this and I will put each digit in its own place and then subtract the places after that to arrive at the result. Okay, so the first one here is the hundredths. I have here 2 minus 4, but I cannot subtract 4 from 2. So I will borrow from 5. So I have here 4 and I will have here 12 parts. So it will be 12 minus 4 equals 8. Next, I will subtract the 10th place. So I have here 4 minus 1 equals 3. Next, I have the 1st place. So 0 minus 0 equals 0. And I will put the decimal point in its place. Okay, so the result will be 0.38 or 38 hundredths. Okay, so if I have an example like this, I have 1.23 minus 1.02 or 1 and 23 hundredths minus 1 and 2 hundredths. So I will shade the model with the first number here 1.23. So I will shade all of this square. So I will shade all 100 parts here first to represent the whole one. Okay, so it will be like this. Okay, Next, I will represent or shade the 23 parts here. So I will shade 2 columns or 2 rows like this, and just 3 parts like this. Next, I will delete the parts that represent the second number. So I will delete just the whole one here. Okay, so all of this square, all of these parts will be deleted, will be subtracted, and I will subtract here 2 parts from the second one. Okay, so what is the remaining parts? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So the result will be here just 21 parts of 100, or 21 hundredths, or 0.21. If I use the place value chart like this, I will represent every number in the place value chart first. I have the first one here, 1.23, and the second one is 1.02. So I have here 1, 1, just 1 unit, like this. Okay, next I have 2/10 and 300th. Okay, the second one I have 1 unit and 0/10 and 200th. Okay, so I will subtract the places from each other. So I have 3 minus 2 in hundredths place, so it will be just 1. And I have 2 minus 0 in the 10th place, so it will be 2. And 1 minus 1 equals 0 in 1 units place, so I will have 0, so it will be just 0.21 or 21 hundredths. Okay, but for the large numbers I will not be able to use the models, so I will use the place value chart or the vertical method. So if I have a large number like this, okay, I have 3204.4 minus 1823.015. Look at the place value chart here. I will represent every number and every digit of the number in its own place. So I have 3200, 0, 10th, 4, ones, and 4/10, 0/100th, and 0/10th. But I don't have 2 zeros here. I put 2 zeros here to make the 2 digits equivalent. I have here 3 digits, so I will make here 3 digits. So I will put 2 zeros to make the decimal digits here 3 digits. So it will be 0/100ths, 0/1000ths, and I will subtract every place from each other. So it will be 0 minus 5. It can't be, so I will borrow from the next digit. So I will have here 4, it will become 3, and 0 will become 10, and I will borrow from 10, so it will be 9, and here I have 10. Okay, so it will be 10 minus 5 equals a 5, 9 minus 1 equals 8, and 3 minus 0 equals 3. Next, I will have the decimal point, and 4 ones from 3 minus 3 ones equals 1 unit, and I have 0/10 minus 2/10, so I will borrow from 2 to it will become 1, and 0 will become 10. So it will be 10 minus 2 equals 8, and 1 minus 8 it can't be, so I will borrow from 3, it will become 2, and 1 becomes 11. So 11 minus 8 equals 3, and 2 minus 1 equals 1. So the result will be here 1381.385, or 385 thousandths. So the result will be like this, okay? 1381, okay? 0.385, okay? But I have here a new method. It will be very useful for the large numbers. It will be the vertical method. So if I want to subtract decimal numbers with the vertical method, first I will put the decimal point under each other. So I have here the first number, I will have the decimal point, and I have the second number with decimal point. Next, I will put the digits under each other. So I have here 4 ones, 0 tenths, 2 hundredths, and 3 thousandths. And here I have just 4 tenths. Next I have 3 ones, and 2 tenths, and 8 hundredths, and 1,000, and I have here 0 in the tenth place, and 1 hundredths, and 5 thousandths. Next, I will put zeros to the right of the last decimal digit, so that each number has the same number of digits after the decimal point. So I have here 4, and I don't have any hundredths or thousandth digits. So I put 2 zeros like this, and after that I will subtract by starting from the right to the left, okay? So I will subtract 0 minus 5, it can be, so I will borrow from 4, it will become 3, and 0 becomes 9, and 0 becomes here 10. Okay, so 10 minus 5 equals 5, 9 minus 1 equals 8, 3 minus 0 equals 3, and I will put the decimal point. Next I have 4 minus 3 equals 1, 0 minus 2 it can't be, so I will borrow from 2, it becomes 1, and 0 becomes 10, so 10 minus 2 equals 8, and 1 minus 8 it can't be, so I will borrow from 3, becomes 2, and 1 becomes 11. So 11 minus 3 equals 11 minus 8 equals 3, and 2 minus 1 equals 1. So the result will be 1381.385, or 385 thousandths. Okay? Okay. Listen to this note. When I add zeros to the right of the decimal of the last decimal digit, like I did here, it doesn't change its value. So I have here 4 tenths or 400 thousandths, it's the same value. Okay, okay. So why don't we try and solve with some examples again? Okay, so I have here 5 minus 5.43 minus 2.21. Okay, it's very easy. So I will put the two numbers under each other. So I will put the decimal points first. I have here 5 ones, 4 tenths, and 3 hundredths. And next I have 2 ones, 2 tenths, and 1 hundredth. Okay, so I will subtract 3 minus 1 equals 2, 4 minus 2 equals 2, and 5 minus 2 equals 3, and I will put the decimal point in its place, so it will be 3.22. Next, I have 8.6 minus 6.51. Okay, so I will say 8.6, and next I have 6.51. But here I don't have any digit, so I will put 1 0. Okay, next I will say 0 minus 1, it can't be, so I will borrow from 6, so it becomes 5, and 0 becomes 10. 10 minus 1 equals 9, 5 minus 5 equals 0, and I will put the decimal point. Next I have 8 minus 6 equals 2, so it will be 2.09, or 2 and 900th. Okay, next I have 97 thousandths minus 49 thousandths. Listen carefully. I have here thousandths and thousandths. It's the same place value, so the result will be just also thousandths, like this. Okay, and I will subtract numbers from each other. I have here 97 minus 49, so I have 9, 7, 4, 9, and I will subtract as usual. Here 7 minus 9, it can't be, so I will borrow from 9, it will become 8, and 7 becomes 17. So 17 becomes 17 minus 9 equals 8, and 8 minus 4 equals 4. So the result will be 48,000, or 0.048. Or maybe I can change the form of this number to the standard form, like 97 thousandths, it's like 0.097. And the second number I have 49 thousandths, so it will be 0.049. So I will subtract as usual with the vertical method, so it will be 7 minus 9, it can be, so I will borrow from 9, it will become 8, and 7 becomes 17, so 17 minus 9 equals 8, and 8 minus 4 equals 4, and 0 minus 0 equals 0, and the decimal point, and 0 minus 0 equals 0, so it will be 0.048. So it's just the same result. Okay, here I have 700th minus 32 thousandths. Here I don't have the same place value. I have here hundredth and thousandths. So if I wanted to change these two forms here to the standard form, so I will say 700th is 0.07. And the second one, 32 thousandths, it will become 0.032. Okay? Here I don't have thousandths digit, so I will put 1 0. So 0 minus 2, it can't be. So I will borrow from 7, it will become 6, and 0 becomes 10. So 10 minus 2 equals 8, 6 minus 3 equals 3, and 0 minus 0 equals 0, and next the decimal point, next I have 0, so it will be 0.038, or 38 thousandths. Okay, but if I want to subtract with this form, what will happen? Next, I will change hundredths to thousandths. Okay, so I know that 700th it's equivalent to 70 thousandths. Okay, so I changed the place value and add 10 because I moved to the next digit to the right. Okay, so I will say 70,000 minus 32 thousandths. So it will become 38 thousandths. And with that, we have finished our video today in which we explained everything related to the subtraction. I hope we understood and benefited from the video and explanation. So if you have any questions, send them in the comments. I will see you in a new video and new lesson. I'm Mr. Ahmed Magdy, your math teacher, and goodbye.